Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we're looking at the cosine rule. Now, the cosine rule works with any triangle. The standard notation for triangles is if you label a corner with a capital letter, then the opposite side is labeled with the same letter, but lowercase. So the lowercase b is opposite the capital letter B for the angle. And given any triangle, the cosine rule has got two uses. First of all, if you know all three of the sides, you can use the cosine rule to calculate any of the angles. And secondly, if you know any two sides and the angle between those two sides, then you can calculate the third side. And that is the cosine rule. It looks quite similar to Pythagoras' theorem, and that's because it is a generalization of Pythagoras' theorem, which doesn't just work for right-angled triangles, but works for any triangle. And if A was equal to 90 degrees, then this term here would cancel, and you would just have Pythagoras. Okay, we'll have a quick look at the proof of this, so you can see why it's true. And we use Pythagoras on these two triangles. So having drawn a vertical from A down to the base, you get two right-angled triangles. And in the left-hand one, you get h squared plus x squared is b squared. And in the right-hand one, you get h squared plus a minus x squared is equal to c squared. Now, solving these two equations simultaneously, by doing this first one, take away the second one. By doing that, the h squareds cancel. And on the left-hand side, we get x squared minus a minus x squared, and on the right-hand side, we get b squared minus c squared. Multiplying out this bracket here will give us that. The x squareds then cancel, which gives us that. And tidying that up gives us c squared equals a squared plus b squared minus 2ax. And the last thing we need to do is calculate x using standard trigonometry from this left-hand triangle here. And x is equal to b times by the cosine of c. So substituting that in gives us the cosine rule. C squared is equal to a squared plus b squared minus 2ab cos c. Now you'll notice that the letters are in a different order there. And the order that you choose to write the letters in will depend on the question. So c squared equals a squared plus b squared minus 2ab cos c would be the cosine rule. But sometimes it would be more helpful for you to write it that way round or that way round. Now, what I would do is try and learn the pattern. That these two ones here that are added together, they're the same two sides that come into here when you have 2ac times by the cosine of b. And the side which is on its own on the left-hand side is always the same letter as the angle on the right-hand side. So that's the pattern. If you had p, q, and r, then it would be p squared equals q squared plus r squared minus 2 times the same two letters, qr, times by the cosine of the letter that you began with, cos p. Okay, let's have a look at an example. Calculate the length of the side AB in the triangle ABC, in which BC equals 6, AC equals 5, and angle C equals 50 degrees. On all of these questions, I would do a quick sketch first of all, just so it's absolutely clear what's going on. Anyway, I'll let you have a go yourself first. So pause the video, have a go, and then come back to me again when you're ready. Okay, let's have a look. As I said, I'd do a sketch of the triangle first of all. Sketching the triangle would give you something like that, where AC is 5, BC is 6, and you'll notice it's the angle in between those two sides that we know. Angle C is 50 degrees. Now we're wanting to work out side C here. What that means is this is the easiest version of the cosine rule to use, where you've got C on its own. So C squared is equal to a squared plus b squared minus 2ab times by the cosine of C. And a, b, cosine C, all of those things we can either work out on the calculator or we know and can just substitute straight in, which gives us 6 squared plus 5 squared minus 2 times 6 times 5 times by the cosine of 50 degrees. And from here on, it is really just calculator work. That would simplify to that, which simplifies to 22.4327. And the last thing we need to do is square root that. When we square root it, we get 4.74. When you square root a number normally, the answer could be plus or it could be minus. But the length of a side is a scalar quantity. It has to be positive, so it can't be the negative value. So C must equal plus 4.74 to 3 significant figures. Okay, example 2. This time we're trying to find the size of an angle. Again, I'd make a quick sketch of the triangle and then have a go at working it out. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look. So this time we know all 3 sides, 7.2, the 6.5, and the 9.8. It's angle B that we're asked to find. That means when we write down the cosine rule, we want to have the B here so that we also have the angle B at the end. So B squared equals A squared plus C squared minus 2AC cos B, because it's angle B we're trying to find. Now substituting what we know, and what we know is all of the sides. So substituting in the lengths would give us that. Tidying that up would give us that. And that means that the cosine of B is equal to this. From here on, it is all calculator work. That division will give us 0.6786. And then we need to do inverse cosine. And that gives us B equals 47.3 degrees to 1 decimal place. Okay, example 3. Now, what's difficult about this question is the sketch. Once you've done the sketch, it's exactly like the previous 2 examples. But the question is all to do with bearings, and you're going to have to work out exactly what you need to draw. I'll read the question and then I'll let you have a go. So a ship B is 8 kilometers from a lighthouse A on a bearing of 60 degrees. The second ship C is 4.8 kilometers from A on a bearing of 18 degrees. Calculate the distance between the 2 ships. Now, a quick reminder on bearings, in case it's a long time since you've done them. The bearing is an angle, and it's the angle measured clockwise from due north. Have a go at this yourself, and then when you're ready, come back to me again. Okay, let's have a look at this. Now, as I said, it's the sketch that's the tricky bit of this question. Now, that's the drawing, and I'll just explain where everything comes from. So here is the lighthouse A, and we're told that the ship B is 8 kilometers from it, which is why this distance is 8, on a bearing of 60 degrees. And that 60 degrees is the angle made by the line AB with due north, strictly speaking, going clockwise from north. And then we're told that a second ship is 4.8 kilometers from A. So the second ship C is here, 4.8 kilometers from A, but this time on a bearing of 18 degrees. And that 18 degrees is the angle between AC and due north, again going clockwise. And we're asked to calculate the distance between the 2 ships. So we're asked to work out BC. Now here's the triangle that we'll be using, ABC. We know 2 sides. We don't know this angle, but it's very easy to work it out. So the angle BAC will be equal to the 60 degrees, take away the 18 degrees. So the angle inside the triangle there will be 42 degrees. We'll be using this version of the cosine rule because it's side A that we're trying to find. So A squared equals B squared plus C squared minus 2BC cos A. Substituting in, B is 4.8 and C is 8, and angle A, as we said, is 42 degrees. From here on, it is just calculator work. That would tidy to give you A squared equals 29.966, and square rooting that gives us a distance of 5.47 kilometers between the 2 ships to 3 significant figures. Okay, the last example. Example 4, in triangle PQR, PQ is x centimeters, QR is x plus 3 centimeters, PR is 8, and angle PQR is 60. Find the value of x. As always, do a sketch of the triangle first and just follow the normal method, trying not to be put off by not knowing the exact values, but having to substitute in x and x plus 3 for the two sides. So have a go yourself, pause the video, and then come back to me again when you're ready. Okay, let's have a look. So there's a sketch of the triangle. The side PQ is x, the side QR is x plus 3, the side PR is 8, and the angle PQR is 60. Now we're not being asked to find any side this time or any angle. What we're being asked to do is find the value of x. But we still use the cosine rule. So this is the angle we know. So we'll be working from this angle and using cos q. And that means this is the side little q, which we'll be starting with. So q squared equals p squared plus r squared minus 2pr cos q. And this time we can substitute in for everything. So that'll give us 8 squared equals x plus 3 squared plus x squared minus 2x times x plus 3 times by the cosine of 60 degrees. Cos of 60 is a half. Multiplying out these brackets gives us that, and multiplying out these brackets gives us that, which we do still need to times by a half. That gives us 64 equals x squared plus 6x plus 9 plus x squared minus 3x. That gives us 64 equals x squared plus 3x plus 9. And that simplifies to the quadratic equation x squared plus 3x minus 55 is equal to 0. Now, that doesn't factorize, so you have to use the quadratic formula. From here onwards, it's calculator work with this to get two possible values for x, minus 3 plus or minus the square root of 229 over 2. Now, if we do minus 3 take away the square root of 229, we'll get a negative value for x. But x is one of the lengths of one of the sides, so it can't be a negative value, which means we only have to take the positive here, the plus. Minus 3 plus this square root. And that gives us x equals 6.07 centimeters to 3 significant figures. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 108 and have a go at exercise 6A. Thank you very much for listening, and cheerio.